Good day viewers, I got this thing all hooked up. As you can see here, I got it on a phantom load, so this is an energy efficient way to calibrate and check my electricity meters. Now you can follow the diagram if you want, same thing, but they just run your power bill up. So if I want to use a 10 amp heater as a load, I'll just hook this up instead of this one. But I'm not only going to run up the power bill, it's going to take longer. Using this method, I can use a clamp meter and precisely to the exact amount of current I need. So I'll get me a clamp meter out and exactly 50 amps through this little meter. And we can see how much intervals this thing's keeping up with. Alright, let's give it a test. So, which is 1.01, so 100 kilowatt hour, 0.001 of a kilowatt hour. So yeah, this 100th will be, should be one increment, and that should go to the 9 and back to 0 for 1 kilowatt hour. So this little 100th dial should do 1 full revolution for 1 kilowatt hour on this wheel. So let's set the camera tripod up and I'll get the clamp meter out. Right, zoom in on that a little bit. Before I do anything else, I run 240 volts. So I've got the ballast hooked up here in case there's any shorts and everything's fine, so I can unplug my ballast and hook this thing up directly. I always plug my ballast in here just in case there's a short or something. Good for check measures. Handy. Bags on 0. Alright. It's on 240. Always double check that, because that's a 120 you know your bloody fuse and it could damage the potential coils. Now it spins that way. That's the normal direction of the load wheel. Alright. Zoom out a bit so you can see me clampy. For 1 amps. But it's working. 240 volts. Yeah, probably haven't got it hooked up righty. This line is going real slow. Turn that down. Turn that back down again and reset this. Easy. Unplug safety first. Okay, well the instrument meter was going very slow compared to this one. So let the load going in there, through this meter and through that way. That's basically what I got, neutral out, going out, phase out, going out, into the in, phase in here, and our load which goes between neutral, which is here. Viewers, I got the code cracked, so to speak. It's a multiplying sort of a terminal set up here. So now I've got 50 is 0, my common is this one. 0 is common. So I've got it on the 50 mark. I'm going to run the full current through it and see what this meter reads. It's on the mark and we'll have a look. And I can see the load wheel and the needle on this meter looks the same speed now. Now I'm getting full, that's better. There we go. to 140 volts max at 47 amps. There's a both at 4 load. Now I think we've got the same amount here. Yep, the 100 is half far between the 0 and the 1. This is half far between the 2 little increments. I think I've got it figured out. Just don't bump any little clip leads there. I've got it figured out now. It's how I wire this here up here. 1, and that's moved 1. Aha! 100 watt hours is advanced. There we go, that's how it works. Yeah, simple. So I can do a phantom load with this thing now. Pretty simple. I make up another one of these, a safer one. 1, 2. Takes a bit of trial and error, I think. When it's catching up, I've got to take into account the resistance of the wire will change and mess up the reading a little bit between the standard and the meter. So I've got to take that into account when I'm doing this sort of a test. 1 to 1.5. That's about past, yeah, it's about the same. Yep. 2.5. And that's the same advancement on an increment. Beautiful. Remember, the wheel's moving that way, the same standard as this one is moving. That's 40 amps going through that. So that's a 50 amp tap there, so I'm safe to run that much through it. Basically how it worked, I did the same thing with these taps, and the current was only maxing it at 2 amps on the 1 amp setting. So it's just wired a little bit differently, but the principle's the same. 4. Yep, spot on. Spot on. Would you look at that? Sweet. And halfway between there, the 4, approaching the 5th one now. It's halfway between the 4th and the 5th increment. This one here is about the same. Beautiful. There we go, that's how these things work. So I'm going to do full current tests at 50 amps with my modern meters, so I'll not use these ones. Another my little Lemco MC3, the old 1930s watt hour meter I got on my first score. Spot on. So I can run the 5 amp test through the old MC3 Emco, the 1934 model one. I could run it against this to do a proper check at low loads. So handy. Yep. On the 6th one now. Spot on. Spot on. We've got a roll over. Let's just go around back to 0 on this dial here, and we should have a 1 full kilowatt hour. Looks like we're looking good so far. This thing's most definitely still accurate, of course, as it should be. I don't see why it wouldn't be. I can't be bothered counting the turns of that needle, how much revs per kilowatt hour this actual meter is. 7. Yep. The 7th one's just starting to pass. 8. Yeah, my wires are changing resistance as they're heating up, so it's messing up the differences a little bit here, but you get the idea how it all works. Pretty cool. That's pretty simple to wire up on a little phantom light. How good's that? She's a hummer. She's humming. Yeah, my wires are heating up. See, look at this. The reading's messed up already. Toward the end, I should turn it down, let it cool down, and then commence the test. Yeah, my wires have heated up. See, I can smell it already. The resistance is changing in my wiring. I gotta get chunkier wiring. So, 105 watt hours difference here. So I'll unplug this. But it could also be using this. But that shouldn't have anything to do with it. That's just to check if I got shorts or not. Probably this wire here. This wire here is probably what the problem is. If I piss this wire off, I get another chunky wire like this one. This will hold up the resistance a bit better. This is only bloody car amplifier hookup cable. So that's probably what the problem is, causing all these losses. The resistance to that changes quite significantly compared to this wire here. So my wiring does have something to do with it, definitely. 0 on the 0 there, spot on. Well, a little bit out. Yeah, with the correct wiring, it should be alright. Now I've got a potential switch here. What would the switch here be for, I wonder? I wonder if that's temporarily stop it or something. Just why get it on the mark. Interesting. But there we are. Yeah, that's probably definitely my wires changing resistance. Same deal when I do the phantom load. One's always going to be advanced more than the other. But that's how you hook these things up on a phantom load. Quite simple. Thanks for watching.